Now let us do one numerical related to Coulomb's law. The question is something like this. You have a square whose side length is A, and you have got four charges, equal charges, Q plus Q plus Q plus Q and plus Q, placed at four vertices. Now the question is to remain them in like a square, or to remain it as a system. What should be the charge which should be kept at the center, so that this still remains like a square? So should you keep a positive charge, or should you keep a negative charge? What should be the magnitude of that charge? That's the question. What is the charge to be kept at the center, so that all the four charges remains in equilibrium? Now when you come across such questions, first of all you have to think, if they all four charges are of positive nature, obviously they will be repelling each other and would like to free away from each other, so would like to move away. So you should keep an oppositely charge, like that is, you should keep a negative charge at the center, so that they still remains, because of the attractive force between this negative charge and the four other positive charges, still remains as a square, so still remains in equilibrium. So the polarity of the charge is understood, it should be negative from the question. Now what should be its magnitude? For that you must find out. Let us draw the figure one more time. This is plus Q. Let this be A point, let this be B, let this be C, and let this be D. Here also plus Q, here also plus Q, here also plus Q. Now if you consider the charge which is kept at A, so this is plus Q, this is point A. If you consider a charge which is kept at A, he will be finding a repulsive force from the charge which is kept at B, and that repulsive force direction will be in this way. That is force on A due to B. Similarly, the charge at A will be feeling a repulsive force from the charge at D, so that will be again force on A due to D. Now since these two forces are making an angle of 90 with each other, you can find its resultant. So you can find the resultant as per the parallelogram law vectors. R is equal to root of P squared plus Q squared plus 2PQ cos theta. Here it is root of FAB squared plus FAD squared plus 2 times FAD FAB, and cos theta is 90 degrees, so cos 90. So this term will become 0, cos 90 will become 0. So you have resultant equals root of FAB squared plus FAD squared. Now what should be the magnitude? What will be the magnitude? So F force on A due to B is equal to 1 by 4 pi epsilon 0. Here it is Q, here it is Q, so Q squared by distance is A squared, so that is FAB. Similarly FAD will be equal to 1 by 4 pi epsilon 0 as per Coulomb's law, again Q squared by A squared. So magnitude wise, FAB and FAD and FAD are same. So let me write it as F. So here I can write root of F squared plus F squared, so you will have root of 2F squared, or you can have root 2 times F as the resultant of these two forces. Now in which direction that force will be acting? So you understood the resultant of the forces, you should also know the direction in which it is acting. So you can have the direction, since it is 90 degree to each other, the resultant will be acting at an angle of 45. So that will be equal to, so this is 45 and this is also 45. So this will be the FR result. That is root 2 times F. Now this charge at A will also experience a force of repulsion from charge at C. So this charge will be repelling, and that force will be acting along the diagonal. So that force of repulsion will be also in the direction of the resultant force. So this is force on A due to charge at C. Now along this diagonal you have two forces. Force due to the resultant of these two, FAB and FAD, and force due to A because of the charge at C. So what is the force on A due to charge at C? Again using the same formula, force on A due to charge at C 1 by 4 pi epsilon 0 q squared by, see, distance between A to C, you know the side is A, this is also A, so this will be hypotenuse. Hypotenuse is equal to A squared plus A squared base squared plus altitude squared, its root. So you have root of 2A squared, or you can have root 2 times A as the hypotenuse. Now in this place of R you can write root 2 times A, its square. So you have 1 by 4 pi epsilon 0 q squared by 2A square as the force on A due to charge at C. So which all forces are acting along the diagonal? That is the resultant force plus this force on A due to charge at C. So if I add both, let me write resultant force equal to root 2 times F, as I got root 2 times F is 1 by 4 pi epsilon 0 q squared by A squared, because FAB and FAD was equal to F. As we concluded, FAB is same as FAD, whose magnitude is equal to F. So I can write root 2 times F is root 2 times 1 by 4 pi epsilon 0 q squared by A squared. Then FAC I have got it here, it is 1 by 4 pi epsilon 0 q squared by 2A squared. Now these are the two forces which are acting on the charge kept at A, and it is being repelled along the diagonal. Now you have to keep some charge at this point, which is the center of the diagonal O, to nullify that repelling force. So you should keep some charge at this point O, so that the repulsive force which is felt by the charge kept at A is nullified, or that repulsive force should be equal to attractive force between the charge which you keep at A and O. Let the charge which I keep at O is X. So the force of attraction between A and X should be equal to force of repulsion which is felt by the charge kept at A. So which all are the force of repulsion which is felt by the charge at A? That is root 2 times this F resultant plus FAC. So it should be balanced by the attractive force between the charge which is kept at A and O. So what should be the attractive force? I don't know, 1 by 4 pi epsilon 0. I know Q, X value I don't know. By how much? The distance is half of the diagonal. So diagonal is root 2 times A. This is the length of the diagonal, as we got for the other equation. Its half will be equal to root 2 times A by 2, so it will be root 2, and root 2 got cancelled, so you have A by root 2 as the diagonal, half of diagonal, that is AO. So here you have to place AO, so it will be A by root 2 the whole square. So this is the force on A due to charge kept at O. This force of attraction should balance these two forces. So if I write them along a line, so it will be root 2 times 1 by 4 pi epsilon 0 q squared by A squared plus 1 by 4 pi epsilon 0 q squared by 2A squared. These are the repulsive forces which is felt by the charge at A. It should be equal to attractive force 1 by 4 pi epsilon 0 q into x by A squared. Now root 2 squared will become 2, that will go to the numerator, so 2. So 1 by 4 pi epsilon 0 q squared A squared, 1 by 4 pi epsilon 0 q squared is not there, so here you have one q remain, or you can take 1 by 4 pi epsilon 0 q squared by A squared out. So you will have root 2 plus 1 by 2 on left hand side. On right hand side you have 1 by 4 pi epsilon 0 q x by a squared into 2. So this 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 can be cancelled. A squared and a squared can be cancelled. Q is there, q squared is there, so 1 q will remain. And on this side you have 2x. So if you write them separately, left hand side you have 2x, and on the right hand side you have q into root 2 plus 1 by 2. So when you cross multiply, you will have q 2 root 2 plus 1 by 2 equal to 2x. So when you write for x, which is the charge which you are going to keep at the point O, so you have x will be equal to q by 4 2 root 2 plus 1. Now since we have already decided it should be an attractive force, then the charge which you are keeping at A is positive, so here you should keep a negative charge. So the value of the charge which you are going to keep at O, so that all the 4 charges remain in equilibrium, as square itself is minus of q by 4 2 root 2 plus 1. Hope you understood how you have to solve. First you find out what all force, take any one charge, find out which all repulsive forces are acting over it. In this case, repulsive force on charge at A because of B, because of D, its resultant. The same direction you have the repulsive force on A due to C. Those forces get added up. Now you keep a charge at O. That repulsive force will be cancelled by the attractive force between the charge at A and O. And from that you find the value of charge which you are going to keep at x. Keep at O, which is x. Hope you understood this problem. Thank you.